question number 8 is there from enthalpy lesson. It's a very basic question. We will see the standard enthalpy values. Delta H is standard D, right? So D stands for dissociation. For the stepwise dissociation of the gaseous methane at a given temperature is given below. So methane, the simplest hydrocarbon you are having, so it will have 4 equal CH bonds. But however, according to the definitions of bond dissociation in the enthalpy lesson, you are allowed to break only one bond at a time. Right? So only one bond at a time. According to that, so you have 4 bonds, even though the 4 bonds are equal. When you are breaking them one by one, you can see the values are different. And there is a reason, because we are doing it one after the other. So then if you break one bond, then the molecule stability will be changed. You can see the bond dissociation was increased little by little. 426, 436, 55, like that it will increase, but it suddenly decreased when you are breaking the last one because of the stability of that remaining part. So then, however, we know these 4 bonds are equal. And so therefore, when we are doing calculations, we are not going to bother about individual bond dissociation energies, right? So we have to have a mean value to use in the calculations. So not only CH4, so the other molecules like ammonia. Also, you have to do the same thing, ammonia and NF3. If you have similar bonds around the central atom, then we are trying to get a mean bond dissociation energy. How do we get the mean value usually? We add all the bond dissociations and we divide by the number of dissociations, right? So then the mean standard bond dissociation enthalpy, to get it, we have to add all the values like 426, 436, 455, and 347. Then after adding them, we have to divide it by 4. That's how we find mean. No? It's very simple. Okay, D1, D2, D3, D4. Division, number of bonds, 4. So we will do the simplification and find a value. Then you divide it by 4. 4, 1, 6, 460. Means the value is going to be positive. Positive 460. Because always bond dissociation is endothermic. Delta H standard D always delta H positive, endothermic. Endothermic means we have to supply energy. If I give you some simple example for the bond dissociation of hydrogen, we will have 1 mole of gaseous bonds and then you are breaking it to its gaseous atoms. That's why we are breaking one by one, because at a time we are breaking only 1 mole of bonds. Right? So then that's why we have to do it for 4 times. That's there in the definition. The definition for the bond dissociation is the enthalpy change that occurs when 1 mole of gaseous bonds is broken into its gaseous atoms under standard conditions. So we are breaking 1 mole of gaseous bonds into their gaseous atoms. Important thing here, when we are having similar bonds for a molecule like CH4, NH3, we are getting a mean value, because when we are doing calculations, we need the mean value, not individual different values. And you can simply go through about other enthalpy changes in the similar way. And you need to know to identify those enthalpies where you see, and you should be able to give the reaction for the given definition also. Okay, if I say CH4 formation enthalpy, you should be able to write the necessary reaction. Develop that skill first of all if you are having trouble with the enthalpy lesson. That's the problem to be corrected. So please go through and pay attention for the definitions. It's important. Not memorizing the definition, writing reactions and understanding reactions according to the definition. That's what needed. Okay, because they will not ask you to note down the definitions. Right. Then we'll go to another